Okay, well, welcome back. So we are now going to be covering homework 5 on polynomials. So the homework 5, quiz 4, and discussion 2 will all be due Monday, September 18th. So as I'm in Ireland and going from place to place, I made sure that I had Wi-Fi. So I will be checking in, looking at your, if you have questions. The problem is I can't be on it all the time. I have to have Wi-Fi, otherwise it's going to cost me an arm and a leg. So I will be checking in the evening on the website and see if there's anything that I need to cover or need to answer. And also remember, you do have tutors available on the Northwest Vista campus. Any of the campuses will have tutoring. And then I do have my colleagues on the Northwest Vista campus that have office hours. So those are posted in the orientation. So if you need to get in and talk to anyone face to face, that will be super helpful. So, okay, so let me share my screen and we are going to continue on with our OneNote. So again, this is our fall 2023. Here's our Math 1324 class. You guys have access to this and you can go back and look at any of the lessons that we've done. All of these from the beginning of the semester are in our Canvas class in the modules that cover. So like in module, the orientation module, the order of operations will be posted in that module, so you can go back and you can review that and stop and start, fast forward, whatever you need to do. Okay, so today what we're going to do is we're going to cover polynomials. So polynomials you've seen already in homework 3 when you were combining like terms. That's part of just your basic operations of polynomials, is being able to add like terms. So you already know what to do with those. So we're going to cover adding and subtracting polynomials. We're going to cover multiplication of polynomials. And I'm going to show you a couple different ways that you can do it. You pick a technique that you like and you stick with it. And then we're going to do one technique of factoring is greatest common factor. And then once I get back into the States and we get back up and running, we'll go over all the other techniques of factoring. Okay, so here are the documents. If you want to print one up, you can go ahead and do that, print one up, and then you can work right along with me as I'm going through these. Okay, so what is a polynomial? So a polynomial in one variable, we'll call x, is constructed by adding or subtracting constants and terms of the form ax raised to the n power. A is a real number, so that means positives, negatives, it can be 0, it can be fractions, it can be decimals, anything in the real number realm. And then n is a natural number. So a natural number is a counting number. It's another term for counting number. So you have, your real numbers, those are broken up into irrational and rational numbers. We spend most of our time in the rational number column. Rational numbers are broken down into integers, which are positives and negatives. Integers are broken down into whole numbers, which are 0, 1, 2, 3, 4, 5, and so on, all the way to infinity. And then natural or counting numbers, the 0 gets dropped and it's only positive values. Okay, so with a polynomial, now I want to make this clear, you can have 0 as a exponent. You can have negatives as exponents. You just can't have those in a polynomial. So if you are looking at something in your MyMathLab and it shows a negative exponent or x to the 0 power, those are considered those are not polynomials. Polynomial has to have a positive whole value as an exponent. So 1, 2, 3, 4, 5, 6, all the way up to infinity. Those are the only values that the exponent can have in a polynomial. Okay, that's when you have one variable. When you have two variables, and we'll call it x and y, that is a polynomial in two variables is constructed by adding and subtracting constants in terms of the form a, x raised to the m, y raised to the n. Again, a is a real number. M and N are natural numbers or counting numbers. Okay, so a polynomial is a very specific way to set things up. So this is a very generalized, a very generalized way. It's not letting me do, there we go. Okay, right here. I want to highlight it. This is a very generalized way to write a polynomial, right? This is just all variables. What you need to be able to identify is A, B, C, D, these letters are what are called coefficients. And all that means is there is a number in front of the X. That's the coefficient, okay? The constant is a number that stands by itself. 1, 7, 3, -2, any of those constants, okay? So a term polynomial, poly means many, and nomial means terms. So polynomial just means many terms. That's all it means, is many terms. Now, when you have a polynomial with 1, 2, or 3 terms, that's a special name. Anything that has 4 terms or more, those are called polynomials, okay? Just the generalized term. So a monomial is 1 term, all right? So what we mean by that, I'm going to give you some examples. If you had 3x squared, 3 is your coefficient, x squared is the variable, right? And you could read this as having 3 x squareds. I could have -4 x to the 5th. So again, as long as my a value, right, this is my a value, is a real number, and my exponent is a natural or counting number, it's considered a polynomial. So this is 1 term. Notice the 3 and the x squared is multiplied, the -4 and the x to the 5th is also multiplied. I could even have 1/2 x to the 100th. That's a monomial. It's a coefficient attached to an x value that has a natural or counting number as an exponent. Okay, that's a monomial. A binomial means 2, bicycle. Okay, so binomial means it has 2 terms. So this is where the adding and subtracting come in. So I could say 3x squared plus 5. The minute I put a plus or minus sign in between 2 terms, now I have a binomial because I have 2 terms. I could have, -3/4 x to the 3rd minus 2. This is one monomial. This is another monomial or constant. When I put them together with a plus or minus, I have a binomial, 2 parts. Or we could have, x squared minus 4. That's also considered a binomial. All right, so anytime you have a plus or minus sign in between terms, now we're adding on to the many parts or many terms, right? The third kind is a trinomial, tricycle, right? 3 wheels. So trinomial has 3 terms. So an example of a 3-term polynomial or a trinomial could be 3x squared plus 2x plus 1. Notice the way I'm writing it is I'm going in descending order. And that's where this part, this part right here, I have n minus 1, n minus 2. All that means is that I'm going in descending order. I have to sneeze. Excuse me. Okay, so that's how you write a trinomial or any polynomial. You want to write it where the exponents are going in descending order, not necessarily the numbers, not the coefficients. So I could have 25x squared plus 10x plus 4. Okay, this is the exponent is what determines the descending order, because this is x to the 1st power. Okay, so 2, 1, 2, 1. So that is in descending order. Okay, so trinomial, I have 3 terms. These terms are connected with pluses or minuses, And I'm going to change this so you have an example of it. There we go, -4. Okay, so anytime you have pluses or minuses in between monomials, you have a polynomial. Okay, now we identify the degree of the polynomial as the largest exponent on the one variable. Okay, the largest exponent on the one variable. And that's what makes this the degree of the polynomial. So if I said, what is the degree of this first polynomial right here? 3x to the 5th plus 2x to the 4th minus 3x to the 3rd minus x squared plus x minus 3. The degree is the largest exponent. So this is a 5th degree polynomial. 5th degree polynomial. This one, largest exponent is 125. So this is 125th degree polynomial. So it's whatever the highest exponent is. That's how you identify the degree of the polynomial. Okay, so now we can work basic operations on polynomials. All right, we already learned in homework 3 the idea of combining like terms. So remember, just kind of a review, when you're combining like terms, okay, the main rule is the variable and the exponent must be equal. Okay, so for instance, if I had 3x squared and 2x squared, right, and I wanted you to add these two, these are like terms because the x squared is what you're looking at. You could literally look at this as I have 3 of these and I have 2 of these, right? How many total? I have 5 x squareds. So the x squared is, think of it as an item. I have 3 of the same item as 2 of the same item. How many items altogether? I have 5. Okay, so that's how you look at your variables. When we're dealing with two-term polynomial or two-term polynomials, let's say I had 3xy plus 2yx. Well, when I first look at this, I go, those aren't the same. But really they are, because we have x to the first here, we have x to the first here. We have y to the first here, we have y to the first here. These are identical. I can switch them, right? I can go 3xy and I can switch these and you can see they are exactly the same thing. So I have 3 of these plus 2 more, I have 5 of these things, okay? So that's the idea of combining like terms. So when you are adding or subtracting polynomials, that is what you're doing. You're combining like terms. So I'm going to highlight these so that we can see what are the like terms. So we have 2x squared and 3x squared. When I add 2x squared plus 3x squared, I get 5x squared. Then I can see I have 6x and negative 2x. Those are also like terms. So when I combine those, 6x minus 2x gives me 4x. And then I have a constant and a constant. So when I combine those, I get 5 minus 1 is positive 4. Okay, so that is one way to do it. You just look through and you go, okay, what is like terms? And I add the coefficients, okay? Or here's another way to do it. And some people like this way. Some people don't like to rewrite things. So they would rather just look at it. But if you line them up, and we're adding, if you line them up in the right order, if you will, right? So this is our x squared column, this is our x column, and this is our constant column. So now it's just a matter of putting them together. 2x squared, 3x squared, I have 5x squared. 6x minus 2x, I have 4x. 5 minus 1, I have 4. Either way, you're going to get the exact same answer. Now, obviously, when I rewrite it, it takes more work, but you can actually see that we are writing them all in the right column. All right. Now, we can do the same thing down here. I'll do both techniques so you can see it. So we have our x squared. So I'm going to go through and highlight all the x squareds. And I end up with 5x squared. Okay. Then I'm going to highlight the y's. So I have 6y. And I don't have any other y's. Okay. So I'm just going to write that. I'm going to add that in. Then I have 3xy. Here's negative 5xy, and here's 6xy. So these are all like terms. So I have a positive 3 and a negative 5. That makes it negative 2. Negative 2 plus 6 is a 4xy. Need more color. Okay. And now I'm done with those terms. This one, I have a negative 5x, or I'm sorry, negative x. So I don't have any other x's. So I can write this as minus x. And then the last one is my constant. Okay. And I don't have any other constants. So I write it as plus 5. So you can put it together as you go, and that's completely fine. I actually like highlighting it. Some people like to cross them off as you add them. It doesn't matter what your technique is, just make sure that you stick with it. So here is adding them where you line them up. So I'm going to rewrite this one, 2x squared plus 6y plus 3xy. And I'm adding 3x squared, so 3x squared minus, I don't have any y's, so minus 5xy, and I don't have any x's. Okay, and then I'm going to put this one and line them up in the right spot. So 6xy, and I don't have any constants, so I'm going to put that out here. So now you can see all the x squareds are in the right column. 6y is in a column by itself. 3 minus 5 plus 6. So you could do this, 3 and 6 is 9. 9 minus 5 is 4. I don't have any other x's, and I don't have any other constants. So again, whichever way you like, stick with it, right? I like this because it's a visual, right? You can see which ones are the like terms. Okay, so now this one, we're going to subtract. So this one, subtraction makes it much more difficult to keep track of everything. And here's why. When you are subtracting, okay, let's go back to adding. When I add, it doesn't really matter what order I put it in, right? I can add 6y plus 2x squared or 2x squared plus 6y, it doesn't matter. But subtracting makes a big difference. So if I had 10 minus 5, that equals 5, right? Pretty basic. But if I switch these and did 5 minus 10, I have a very different answer, right? If we're looking on a number line, here's my negative 5, here's my positive 5. These are two completely different answers. Okay, so subtraction order matters. Okay, addition order doesn't matter, but subtraction order matters. So when we're subtracting and we have parentheses, you have to remember that this negative in front of the whole set of parentheses means I am pushing or I'm multiplying that whole set of parentheses by -1. So I can rewrite this as negative 4x plus 7 minus 1 times 5x minus 3. And then I'm going to distribute that -1 through. So I end up with negative 4x plus 7 minus 5x, because -1 times 5x is negative 5x. And a -1 times a -3 is a positive 3. Okay, once the parentheses are gone, now I'm just going to add like terms, right? So I have a negative 4x and a negative 5x. So that gives me negative 9x. And then I have constants. +7, +3, which gives me a +10. Okay, so once you get your distribution, right? Once you distribute, those parentheses go away. You have all the right signs, and now you can add your like terms. Okay, so subtraction really changes things because you're not just subtracting the 5x, you're subtracting this whole binomial, the 5x minus 3. Okay, so this distributing the -1 through is one way to look at this. What I like to see it as, I'm pushing this negative through everything in the parentheses. So this negative becomes a positive, and every term changes signs. Okay, let me do that above it so we don't mess up the. So this becomes a -2x, this becomes a +5x, and this becomes a +12. All right, because we're adding the opposite, which is exactly the same as multiplying -1 times 2x squared, and I get a -2x squared. -1 times -5 becomes a +5x, and -1 times -12 becomes a +12. So now I can add my like terms. Okay, so I have my x squareds, which gives me 4 minus 2 is 2x squared. I have my x's, so 8x and 5x gives me 13x, and I have my constants last. So the constants will always be the last thing that you add. So -7 plus 12 is a +5. Okay, and there is your answer. Okay, now notice there's no equal sign. So these are just expressions, right? We're not solving for x. If this had an = 0, then we would have to solve for x, but we're not there yet. All we're doing is we're just adding our like terms, adding or subtracting our like terms. Okay, now it's the same technique when you are using decimals, right? The coefficient in front just tells you how many you have. You have 1.5 y cubes. You have 4.8 y squareds. You have 1 y cubed. You have 1.7, a -1.7 y squares, and you have 2 y's. Okay, so that's all the coefficients in front will have you do, or how many you have. All right, so here we go. I'm going to push or distribute this negative through all three of these. So what that means is I am adding the opposite. I end up with a -y cubed, a +1.7 y squared, and a -2y. So adding like terms. So I'm going to do this where I stack it, just so you can see that, because I haven't stacked it yet. So 1.5 y cubed plus 4.8 y squared plus 12. Okay, so y cubed, I have a -1 y cubed, and you don't have to write the 1, but I just want to do it for clarity. So when there's no number in front, it's a 1, because 1 times y cubed is y cubed. So because it's a negative, we have a -1 y cubed. And then we have plus 1.7 y squared. I don't have any constants in here, so I'm going to move this -2y to the outside. So 1.5 y cubed minus 1 y cubed, I have 0.5 y cubed. 4.8 plus 1.7, that's 15, carry my 1. So 6.5 y squared. And I'm going to just bring this -2y plus 12. All I did is I just brought this here and this here so that it is in descending order. Okay. I'm going to rewrite that just so it makes it clear. So remember, there's no y term. I'll do it this way. There we go. Now it looks a little better. Okay, so there is your solution. or answer to the polynomial. Okay, now remember, order matters when it comes to subtraction. Okay, so in your My Math Lab, I know you have one like this. It says subtract this polynomial from this polynomial. Okay, so if I said I have $10 and I'm gonna take 5 from it, I'm taking off 5. I'm starting with the 10 and I'm taking off 5 from it. So it's the same idea. You're starting with the 6x to the 4th minus 3x, that should have been to the 3rd, plus 2x squared minus 3x plus 2, this should have been to the 3rd. Okay, so you're taking this and you're subtracting this from it. You're taking this out of it. So I'm stacking it, 3x to the 4th minus x cubed plus 2x squared. Now, remember, even though I stacked it, I'm subtracting that. I'm taking this first one out of the second one. Okay, so when you do that, you have to remember you're pushing that negative. So I'm going to add the opposite. This becomes a negative 3x to the 4th. This becomes a positive x cubed. And this becomes a negative 2x squared. So now they're stacked. I've subtracted, which means I've changed the sign. And now I can work my magic. 6x to the 4th minus 3x to the 4th is 3x to the 4th. Negative 3x cubed plus 1. So I have a negative 2x cubed. I have a 2x squared minus 2x squared. So these cancel. And then I have a minus 3x plus 2. And I am done. Okay, so that's your adding and subtracting. All right, so this one right here, I'm going to put a star by it because this one is what catches people very often. If it says subtract one from another, this other should be the first thing that you start with, right? This is what you start with. You're taking this one out of it. Okay, all right. So the next thing we can do with polynomials is we can multiply them. All right, so what we're doing is we're multiplying a monomial by I don't know how that became a trinomial. Because here's a monomial, 1 term. Here's a trinomial, 3 terms. Okay, I'm gonna have to change that. All right, so monomial by a trinomial. So all we're doing is we are using the distributive property. Okay, now again, there's a couple ways that you can do this. Whichever way you feel the most comfortable with, you need to stick with it. So if I'm using the distributive property, what I'm doing is I'm taking the 3x and I am multiplying it by every single term. And don't forget your sign. So I'm taking the 3x and I'm multiplying it by the x squared, by the negative 2x, and by the 1. So when I do that, remember when we are multiplying, and we'll talk more about exponent rules, but when you're multiplying with exponents, you add the exponents. Okay, so when you multiply with exponents, you add the exponents. Okay, so for example, if I have 3x times x squared, what I'm doing is I have 3x times x times x. You see it? I have x squared here. Here's my x squared. And here is my x to the 1st. Well, how many x's do I have now? Well, remember, we're not adding the x's. We're multiplying the x's. So what this ends up being is 3x cubed because I have 3 x's here. Okay, not because of this, but because I have x times x times x. which means you are adding the exponents. Okay, so this ends up being 3x cubed. So all I'm doing is this is x to the first, 1 plus 2 is 3. And here I have 3 times -2 is -6. So you multiply the coefficients. And then when you are multiplying with variables, x times x is x squared. And then 3x times 1 is just 3x. So when you multiply, you end up with 3x cubed minus 6x squared plus 3x. And all I did is I multiplied the monomial by every piece inside the parentheses. So to do this, here's the shortcut. This is the long way, right? Just to make sure that you're understanding how I'm getting my values. But the shortcut is I multiply 3x times x squared. So I get 3x cubed. 3x times -2x. I get -6x squared. 3x times 1 is 3x. Okay, so it's literally just multiplying each term by everything on the inside. Okay, we're going to try one more. So this is a monomial by a trinomial. And this technique works, doesn't matter what polynomial you're using, this technique will work. So let's say we have a -2x to the 4th. And we're going to multiply that by x squared minus 3x minus 2. Okay, so distributing and adding the exponent. You multiply the coefficient, so -2 times 1, and you add the exponent. 4 plus 2 is 6. Okay, and a -2 times a -3, you multiply the coefficient, you add the exponent. So x to the 4th times x is x to the 5th. -2 times -2 is positive 4, x to the 4th. So there's another example. Okay, and all we're doing is just multiplying the monomial, the outside, times everything on the inside. Okay. All right, so this one, when you're multiplying a binomial by a binomial, there's a couple different ways that you can do it. Every single way, what you're doing is the distributive property. That's what you're doing. Mathematically, that's what you're doing. Some people use what's called the FOIL method, which is still distributive property, okay? Others will take, because we're multiplying this binomial by this binomial. So one technique is I'm going to take the first binomial and multiply it, just like what we just did. Okay, so this is the monomial 3x times the binomial x minus 1, and the monomial 1 times the binomial x minus 1. So when I do that, I end up with 3x times x is 3x squared. 3x times -1 is a -3x. And then 1 times x is, notice I am lining them up in the right order. And 1 times -1 is a -1. And then I'm just going to add. So 3x squared minus 2x, because -3 plus 1, and then minus 1. Okay, that's one way to do it. Just distributing. Okay, FOIL is just distributing in a very set way. And it's an easy way to remember it. The problem with FOIL is it only works with a binomial by a binomial. That's the only time FOIL works. So that's why I don't use that term very often. Okay, so here's where FOIL comes from. F is first. 3x times x is 3x squared. Did you notice what we just did here? There's your first. Outside, this is first. Outside, 3x times -1 is a -3x. There's your -3x. That's this one right here. Okay. And then inside is 1 times x is x, which is right here. And then last is 1 times -1, which is -1. Okay, so there's your last, there's your inside. So for first, outer, inner, last. And all we're doing is the exact same thing. First, outer, inner, last. It's the exact same thing. So now we just put it all together. 3x squared minus 2x minus 1. Exact same answer, two different techniques. Okay, again, you pick a technique that works for you and you stick with it. All right, let's try it one more time. So again, if we were in a live Zoom class, I would say, okay, you guys go do it, put it in the chat box, and let's see how many right answers we can get. Okay, all right, so here we go. I'm just going to do it in the FOIL technique. First, 2x squared times 3x cubed is 6x to the 5th. Outside, 2x squared times -1 is a -2x squared. Inside, 1 times 3x cubed is plus 3x cubed. And last, 1 times -1 is -1. Now with this one, you can see there's no like terms, right? It's not in descending order either. So what we want to do is we always want to write it so the exponents are in descending order. And that is the correct answer, just by doing FOIL. FOIL's a lot faster, just because you're doing most of it in your head. Okay, but if you need to see it, if you need to see all the steps, then write it out just like that. Okay, so FOIL only works for binomial by binomial. These are binomial by trinomial. So this is where your distributive property has to come into play. All right, so I'm going to write this out. I'm going to take my first term and multiply that by everything in the second parentheses. Then I'm going to take my second term and multiply it by everything in the parentheses. And then I'm going to put it all together. Okay, so here is the first term, and here is the second term. So however many terms you have in the first set of parentheses, that's how many times you're going to multiply through. All right, here we go. X times x squared is x cubed. X times -x is -x squared. X times 1 is just x. Okay, so now I can put it in the correct column. 1 times x squared is x squared. 1 times -x is -x. And 1 times 1 is 1. So x cubed gets brought down. My x squareds cancel. My x's cancel. And all I have left is x squared plus 1. Okay. And the better you get at this, the more you will, the faster it will be. It will be much faster. Okay, so this is one technique, right? I just wrote out each term. Now I'm going to show you another technique. This one, I'm not doing FOIL, but I am taking the first term and I'm going to multiply it by every term in the second set of parentheses and get an answer. Okay, so 2x squared times 3x cubed is 6x to the 5th. 2x squared times x squared is 2x to the 4th. 2x squared times a -2 is -4x squared. Now I'm going to take my second term and multiply it by every term in the second set of parentheses. So -5 times 3x cubed is -15x to the 3rd. Notice I don't have an x to the 3rd, so I'm making another column. Okay, and then -5. I'm going to move this over actually. That'll make it easier. So -4x squared. Okay, so negative 5 times x squared is a negative 5x squared. So now I can line them up under the columns. And then negative 5 times negative 2 is a plus 10. And now I can add everything up. So nothing to add to x fifth, nothing to add to 2x to the fourth, nothing to add to the 15x to the third. But now I have negative 4 and negative 5x squared. So I have negative 9x squared and nothing to add to the 10. So that is the correct answer. Okay, so two different techniques, exactly the same thing. It's just the first one, I wrote it out. The second one, I just did it and wrote down the answers as I went. Okay, but the technique is the same. All right, here we go. Now you need to look for a pattern. Okay, these are just binomial by binomial, right? So we're just gonna multiply it using FOIL, or you can set it up this way. Okay, you can do it both either way. So if I do FOIL, first times first is x squared. Outside is 5x. Then inside is negative 5x. And last is negative 5 times 5 is negative 25. When I add these, I get x squared. Those cancel, minus 25. Watch for a pattern. Same thing here. First is x squared. Outside is 10x. Inside is negative 10x. And last is negative 100, right? When I add them, I get x squared minus 100. Okay, so this one I lined them up, this one I did not. I'm trying to show you different ways to do it so that you can pick a way that you like and stick with it. Okay, let's try one more and see if you can find a pattern. First, outside, inside, last. When I add them, those cancel and I get x squared minus 9. So what are the things that you notice? Did you notice that the outside and the inside cancel every single time? Okay, so why is that? Why do they cancel? Well, when you look at your binomials, you have the exact same values or same set of numbers and variables. One is minus, one is plus. One is minus, one is plus. One is minus, one is plus. And if we switched them to have a plus and a minus, it would be the exact same setup. So what's nice about that is you can look at this and go, oh, there's a pattern to this. I don't have to do all this work. When I have the exact same values, one's plus, one's minus, watch how easy this is. You can do it mentally. X times x is x squared. Outside is negative 4x, inside is positive 4x, those cancel. 4 times negative 4 is negative 16, and I'm done. Right? These are called difference of two squares. Difference of two squares. These are the types of problems that we're going to be factoring. Well, look, x squared is a perfect square, x times x. 16 is a perfect square, 4 times 4. Difference means subtraction. And this is going to be super important when we get to the factoring techniques. Okay, so try this one. X times x is x squared. Outside is 7x, inside is negative 7x, so those cancel. And then negative 7 times 7 is a negative 49. Those are both perfect squares. Now, those look pretty simple, right? So now let's try this one. Let's do the exact same thing. 3x times 3x is 9x squared. The outside is 3 times negative 2 is a negative 6xy. The inside is a positive 6xy, so those cancel. And then the last is 2y times negative 2y is a negative 4y squared. These are both perfect squares. 9 is 3 and 3, 4 is 2 and 2, and x squared and y squared both have even exponents. Okay, so difference of two squares. You can do it mentally. You can see how much faster it is. Okay, so that's all multiplying polynomials. Now we're going to spin it and go in the opposite direction. And what that means is we're going to split the value apart, or the polynomial apart, and end up with two things that you multiplied together to get this. So when I look at this, when I look at the values 3x minus 6, what I'm asking is find the greatest common factor. In other words, what do they have in common? And what we're going to do is we're going to find what did we multiply together to get 3x minus 2. And this is called factoring. This is the first technique in factoring, where you're looking at it and you're going, all right, what do all three terms have, or all terms have in common? So with this one, there's a 3 that I can divide out of both of these. 3 can be divided by 3, and 6 can be divided by 3. So if I factor out a 3, okay, what I'm doing is when I say factor, what that means is division, right? I'm dividing out this value, right? So because when I multiplied something together, I got this 3x minus 6. Now I'm going to go in the opposite direction, and I want to find out, well, what did I multiply together? So when I take 3x divided by 3, all that does is it gives me an x left. And let me show you. 3x divided by 3, right? The 3's cancel, so all I have left is x. What about negative 6 divided by 3? I end up with a negative 2. So when I ask for the greatest common factor, I am asking for what's in common, but also when you divide that out, what do you have left? And the beauty of this is you should never get these wrong, because if I multiply this back through, I'm going to end up with 3x minus 6. Okay, exactly what I started with. So these are the factors of 3x minus 6. It's what I multiplied together to get 3x minus 6. Okay, and we always start with, okay, well, what's in common? Well, on this one, what's in common? Well, 15 won't go into 5, but 5 will go into 15. So 5 is a common factor. Now look at the variables. You have x squared and you have x. So what you're going to factor out is the lowest exponent, right? Because I can't take x squared out of x, right? I can't do a bigger number out of a smaller number, but I can take x out of x squared. So 5x is our common factor. When I divide, 15 divided by 5 is 3. I have 2 x's on top and 1 on bottom, so I can cancel one of them. Okay, you can look at it this way. 15xx over 5x. So 15 divided by 5 is 3. I can cancel one of the x's, so I have an x left. All right, now the other part of that, another way to look at this, is remember when we were multiplying multiplying exponents, we added? Well, here we're dividing exponents, so we're going to subtract. And again, we're going to get even further into exponent rules later. So this will come back again. So 2 minus 1 is 1, so x to the first power. So either way, it works that way. And then 5x divided by 5x just equals 1. So 15x squared divided by 5x is 3x. 5x divided by 5x is just 1. Can I double check? 5x times 3x is 15x squared. 5x times 1 is 5x. So these are the factors of 15x squared plus 5x. Okay. All right, now we have a trinomial. What is in common? Well, we have a 7, a 14, and a 21. So what will go into, should have been an x. Boy, I messed up on this one. This should have been x. So we have a 7, a 14x, and a 21. So obviously 7 is in common. We have x squared, x, and no x. So x is not in common in everything. So all we can factor out, the greatest common factor is just 7. So 7x squared divided by 7 is just x squared. Negative 14x divided by 7 is just negative 2x. And 21 divided by 7 is just 3. So 7x squared divided by 7 is just x squared. Negative 14x divided by 7 is negative 2x. And 21 divided by 7 is 3. So you can write it down like I did over here on the side, or you can do it mentally, where you just divide out each part. Okay. All right. Now we have two variables. This is a polynomial in 2 variables. So you do the exact same thing. What do they have in common? They have a 3 and they have an x and a y in common. When you divide 3xy divided by 3xy, you end up with 1. When I divide negative 6xy divided by 3xy, I end up with negative 2. So it's 1 minus 2. So I have 3xy times negative 1. Okay, I just saw what this was. Okay, so you end up with a negative 3xy. Well, if I added like terms on this, I'd end up with negative 3xy. Okay, so sometimes they throw in a little, screwball on you. Okay, last one. So, this one's even bigger. This is a polynomial in 2 variables. Okay, so we just got to remember to keep it separate. You have the coefficients and you have the variables. So first thing you want to look at is what is in common with the coefficients. So you have 9, 18, negative 27, and 9. So 9 is the common value, okay, the common coefficient. Now you look at your variables and you go, okay, we can take out, none of these are like terms, so we don't want to add anything. But we can take out 1x out of each thing, because we have x here, x cubed, x squared. And we can take out 1y out of each term. Okay, so now we're going to do our division. So we have 9x squared y over 9xy. So the 9's cancel, the y's cancel, the x's, all I have left is an x. Okay, 2 minus 1. Plus, and then we have 18xy divided by 9xy. So 18 divided by 9 is 2. The x's cancel and the y's cancel. Negative 27x cubed y squared divided by 9xy. So negative 27 divided by 9 is a negative 3. I have x cubed on top, x on the bottom, so I have x squared. 3 minus 1 is 2. I have y squared divided by y is just y, or 2 minus 1 is 1. So I have minus 3x squared y, and then 9xy squared over 9xy. The 9's cancel, the x's cancel, and all I have left is a y. And that's it. So remember, you can always distribute back through, and you should come back right back to what we started with. Okay? All right, we're going to stop there. And see you next time.